Well, good morning. Happy Thursday. Happy spring. Hope you're enjoying the weather wherever you are. And thank you for attending our webinar today. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And today we're going to look at a extension for Creo called Creo Simulate. And the whole point of utilizing Creo Simulate is to empower your design and engineering teams to use this CAD tool, this analysis tool, upfront while they're designing so that they can optimize their designs instead of doing it downstream and having somebody after the fact, whether it's a specialist, an analyst, um, run an extensive tool that might take days or weeks to run. If that's what you're doing, then using Creo Simulate up front will basically prove that out. So then you can move on to the manufacturing process. If you don't have an analyst or somebody with a high-end tool, then you can just use Creo Simulate all the way through, which is a beautiful thing. So we're going to learn more about this today. Andrea Francis from PTC's Virtual Center of Excellence is going to give us an overview and a brief demo on Creo Simulate. So if you have any questions, please put those into the chat box. We will try to answer them as we go along. Thanks for being on, Andrea. Take it away, kid.
Thank you, Rob. And hi, everybody. Like Rob said, I'm Andrea Francis. I'm a solutions consultant at BTC, and I will be walking you through Creo Simulate, what it is, and really how to use it today. So as I go through this, feel free to drop in questions through the Q&A. Well, we can go through those throughout or at the end, depending on timing. But yeah, feel free to drop those in as I go along throughout the demonstration. So to start with, what even is Creo Simulate? Why do we have this tool inside of Creo? Why did we even think of making this tool? So just a bit of history on it. It's one of the many different tools that we have for simulation inside of Creo Parametric. It's probably the oldest one that we have. It's been around for a really, really long time, and we've evolved it through the years to kind of cover a lot of different bases when you think about simulation. And the reason as to why we even thought of bringing in the CAE tool inside of Creo is, like Rob said, as you're going through your designing process, as you're going through from the concept all the way to the detailing, you want to be able to validate what it is that you're doing, whether it's getting ideas across and running a quick simulation to see if what you've done kind of makes sense within the certain conditions that your product are going to be working in, or if you want to even validate as well. So a lot of times when you design something, you want to ensure that you're validating, you're getting specific metrics for that. And this is what this tool has been made for. It's bringing in simulation capabilities inside of Creo, so you do not need to move back and forth between your CAD environment and a simulation environment. Now, as far as simulation goes, there's a lot of work that needs to be done when you think about your regular simulation. Oftentimes, it's a PhD job that you need somebody that has run this for a while, whether it's FEA or CFD, whatever sort of analysis that it is. You need an expert to be able to do that. And they have their own tools. They know how to use those tools, but you need to provide them with the model for them to be able to run the simulation on. And when you basically take in the information from the CAD into that analysis tools, there's a bit of work that needs to be done. Usually you need to defeature the model, you need to prep it, you need to translate it to a format that that analysis tool is going to accept. A step file is an example of that. And then they would run their analysis, and if they find a problem, there's a lot of issues around that too. So depending on how big the problem is or what needs to be fixed, sometimes they go in and try to fix that themselves in the analysis tools. A lot of analysis tools allow you to do that. But what they're fixing on is a neutral file. It's not actually the CAD file that has all of the features. And then if it's a bigger problem that you haven't caught on early enough, that causes a lot of back and forth that needs to happen between the analysis team and engineering, and you want to try to avoid that as much as possible, especially in the later design stages, because fixing that costs time and money. That's what it is. Now, with Creo Simulate, we're trying to circumvent and prevent all of that from happening. So we're bringing the simulation tool inside of Creo instead. And there's a lot of advantage to doing that. First of all, you basically are working inside of Creo. You do not need to go to a different software. You do not need to prep your models or anything. And we'll talk through that. There's different analysis that you could run inside of Creo Simulate. It mainly focuses on structural and thermal analysis to start with. You can run like your stresses, deflections, frequencies, heat transfer paths, and just different factors to optimize and understand the performance of the product. Now, if you're looking to do other types of simulations, we have other tools for that as well. This will just focus in on the structural and thermal side of things. But like I said before, you are working solely inside of Creo. You do not download the different software. You're not even like transferring anything as far as the CAD goes. You're working on the CAD that you designed with all of the features. So when you're running your analysis, you do not have to prep the model. You don't have to translate to a different type of file. It's all integrated, and you can basically take in that file, set up the simulation, and run it. And if there's any changes, whoever is running the analysis could go themselves and make that change. So if it's an analyst working inside of Creo, they can go back in, change some of the features, and then rerun the analysis. Or the design team can easily understand what those changes are and make them themselves. Now, this is a tool that doesn't necessarily need to use the Creo data too. So if you have like a SolidWorks file or a CATIA file that you import it in inside of Creo and have assembled it in, but you still need to run in some simulation on it, this could also take in those files, similar to all of the functionality inside of Creo where you can bring in different types of file formats. This can do that as well and run simulations on it. So we're enabling your designers to basically make better decisions overall with this. As far as what it could do as well, back to that idea of we want to be able to optimize, we want to be able to iterate on the design as much as possible and get the most optimum part that we can. There's different tools inside of this that are not just running your normal FEA, but optimization and feasibility studies. This will actually allow you to set up studies with goals in mind. And that goal could be, I want to decrease the stress in a certain area without compromising on, of course, structural integrity. And I want to be able to manipulate my features, like the dimensions of something, the length, the round, the thickness of something. I want you to be able to iterate on all of the possible combinations of those metrics and parameters within a specific range that I set. And then Creo will compute all of those iterations and get you that most optimum result based on the goal that it is that you set. And we'll talk about that. So when you're using this tool, you're not just getting an answer to something, you are getting the right answer to it. Whether it is from a structural perspective or from a thermal perspective, you want to ensure that that model is the right answer to the loading condition and the work that it's going to do out there. So as far as capabilities, there are different capabilities. I talked from the structural and the thermal side of things. You can set different types of contacts, different types of materials, whether they are linear or nonlinear. And so this tool, these are a lot of the improvements that we've done for it. You can also work with dynamic and pre-stress sort of analysis, large deformations, isotropic and composites materials. So there's a lot of advanced capabilities for it. And then as far as the setup goes, of course, it goes through the normal setup of I want to set up my constraints and my loading conditions. And then as far as the mesh, we have capabilities for both automatic, of course, manual meshing as well, and then advanced meshing tools, where if you let it automatically set the global mesh and kind of take the model and set up one that is ideal for that model, you can go in and refine that if you wanted to. For the meshing support as well, it supports different types of geometry. If you're working with shells, with beams, with springs, with masses, with solids, it supports all of those. And you can override, of course, if there's something you're not satisfied with, you can override that. For the optimization and feasibility studies, this will, like I said, it will let you set a goal that you want to optimize for, and then you could set a range for one or multiple parameters you want it to iterate on, and then it will do all of that for you in the background and get you that answer. And then for the results, you can output the results and take a look at them. There's templates that you can set up where you can do like a 3D sort of view with different types of metrics you might want to analyze. You can output to different formats. You can query the results. There's just different visual metrics you can take a look at from a results perspective. So I don't see any questions for now. I'm going to jump into the demonstration to show you just a brief example of what this looks like. Okay, so I'm inside of Creo. This is Creo Parametric, and we're going to work on this very simple bracket. You can see it's like a very thin sort of bracket that we're working in. First of all, to launch up Creo Simulate, we have an application, the Applications tab that we're going to set up. So this is one of the extensions you can add on to your Creo license, and then this will allow it to basically launch up as needed. But once we have that set up, we would choose between a structural mode or a thermal mode for the study. So going from left to right on our ribbon, this is the setup of the study itself. We will choose the type of study that we want to run, the model setup. So this is just around the criteria and some of the settings you want to set up, the loading conditions, and those will change based on if you're having a thermal mode or a structural mode, the constraints, the materials, and then running the study as far as functionality goes. So we have all of those available. Let's say we have the displacements, planar, pin, ball, the materials themselves, and then the different types of running conditions we can have. Now, let's say I want to set up one of my constraints, right? I would select on that displacement as a constraint. For example, I would select my references so I can go and pick onto my model geometry the references that I want to have for that. It's easy to really do. All of that, you're just picking onto the features that you want to incorporate. I would set up my force, my moment, my pressures, any of those that are needed really to bring in the information. Of course, the metrics for that. So what is the amount of force in specific directions? I can even go in and put in different distributions. So if I have like a total load at a point versus a bearing load, I can toggle between those different types. And then I would, of course, choose onto the reference with my datums, pick onto the units and the magnitudes of all of those that I need for the conditions that I have. It lets you preview them so you see if you actually set it up properly in the correct direction. So just making sure that those are correct. And then for the analysis itself, you have options as far as which analyses it is that you want to run. So there's different tiers to Creo Simulate, and this is going into the packaging. There's a normal version of it, and then there's a more advanced version depending on the more complex types of analysis that you want to run. So your normal static structural, this would be in the base license, and then going into the more like the dynamic or the pre-stresses, those would be more on the advanced side of things. But let's say we just want to run something simple for ourselves. Let's say I want to do some static analysis. I would set up the definition for that study after I set up, of course, the loading conditions for it. We have our bracket we want to analyze for that. Those are the loading conditions. You have methods too as far as how you want to run and how much you want it to iterate while it's computing in the background. So you can do like a single pass for the study, or you can do multiple passes. This is really around calculating based on polynomial order and how we want that to converge and how many times. So we can go in and manipulate that as far as the limitations go. So let's say I want to set that limit to 6 and then let it compute. You can set as many of those as needed to. So if you want to run multiple different studies, you could, but let's say we just want to run one as an example. We can have it running, and then we can even see it in the background, what it's doing. So this would be just a computation in the background. And then when it's completed, we can open up our results section to see what that looks like. So this is a template that we could create to just show us the information. So we have the animated stress, we have the displacement. We can, of course, go in and toggle between the available options as far as what we want to see with the results. And then if we're happy, that's really good. But if this doesn't really satisfy what we want to do, that means we need to make changes. Now, you can easily come back into Creo, go and make that change directly with the features, add, remove, edit, whatever it is that you need. From here, rerun the study and get different results. But you might have different conditions that you want to try. You might want to iterate on different values. Let's say I want to try the length of this bracket to be within a specific range. I want to try those different ranges or those different values within that range. I might want to try something around the thickness, maybe the round that I have on it. I want to try all of those out. And easy way is to go in and input those manually, make the change every single time to that parameter and rerun it. But that could be really tedious. It could be very manual. It could take a lot of times that I genuinely do not want to spend on all of this. I could set up either a sensitivity study or an optimization study, and there's a bit of a difference here. With the sensitivity study, we can calculate the changes of our measure. And let's say we want to look at our stress and our displacements. And when I vary one variable over a specific range, I want to see how that affects my stress or my displacement. So I can set that up. So let's say this is the analysis that we did. So we're going to take the results for that. I'm going to go in and grab one of the parameters that I want to test for. I could set a range for that, and then I could even set the incrementation as how many steps I could have it go for, and then let it run. And then once it's running, what it will do is it will compute for every single value within that range. It will give me what that stress is going to look like. So I can graph that as well. There's graphing capabilities. We can choose onto the metrics that you want to analyze for. So let's say we're looking at the stress versus all of those ranges, we will get that graph of, we can see there's a clear relationship here. If we change that fillet or we change that around, and then our stress decrease as we increase that. So we can see a bit of a correlation. Now, this is useful if we want to understand what are the variables that are affecting our results mostly, and it's on a one-to-one basis that it could be done. We could do something different with optimization studies. And this will allow us to go in and adjust multiple variables, like all of those rounds that we have, the thickness, maybe the length of something. And this will let me choose onto all of those, create a bit of a matrix at the bottom, which you'll see. And then we can set that goal in this case. We can set the goal of, I want my stress to be under a specific value. And I want my displacements or my deformation to be under that specific value as well. So we can set those goals up and all of those variables and let it compute for that instead of just showing us what variable affects that metric. So let's say this is my optimization study. I could do a feasibility study as well, but I want to minimize or I want to maximize something. So I might be interested in the total mass and I want to decrease that total mass, but I want to also take into account the stress that we have and it needs to be under that specific value that we're going to set. I could add more if I wanted to. So you can add in the displacement if we're looking at torsion versus bending, all of those different factors that we might take into account. You can build up those limits for the design itself and then bring in the variables. So we're going to bring in that same round that we had initially, and we're going to set the range for it. but I want to add more than that. I just don't want to change that single round. I want it to actually compute for me all of those. So I can reflect all of the dimensions onto the model and then pick on them as I need. I might have analyzed which ones are the most important ones that I want to bring in here and have changed. I might not bring everything. I could bring everything if I wanted to, really, but that would really change the shape of the model. If I'm okay with that, that's great. If not, that's where I could go and pick on it. And then you see I built my matrix. All of those have their individual range, so those could be different ranges depending on, of course, the feature and the parameter that you have. So let me go in and change them. And then let it compute. Now, the difference here is this will compute that result for me, and it's going to optimize for that shape. It's actually going to go in and try out all of those variables, of course, within the limits of what we have set for the goal. But this will give me the metrics that are the most optimum ones for those limitations. So it will tell me this round needs to be this value, this thickness needs to be this value. And like here, it's going to go ahead and compute all of that. We have all of those, we have the goal, we have the run completed. And then we can view that as a result, and you'll see a bit of a difference now with the shape of this bracket. It's a completely different bracket. We have that optimized, and we can actually bring that back inside of Creo and have it optimized for us and have it changed for us automatically, so we don't have to go in and make that change ourselves. So we can take a look at the history too. We can see each individual step and step through each iteration that it went through as far as the calculation goes. So we can see actually changing those values incrementally as it runs the simulation. So we want to see where it got that value from. And then we can let it give us that final shape that we started with and be good to go with that. So that's a bit about what you could do with a Creo Simulate. Really, there's a lot of different functionality that we could do with it. It gives us a lot of capabilities, a lot of validation, and makes our job easier, really, as we are designing. So if I go back to my presentation, if I want to summarize what it does, you can create a very low cost for your product. You can discover your flaws as early on as possible. You can let it do that for you. If you set up the limitations properly, it could do the job for you and iterate for you as it goes. And then you can just get the job done faster. Instead of going from a tool to another tool and having to go back and forth, you're working within the same exact tool, still getting your accurate results, but now the changes are easier, the communication is easier, and you're not working in two different systems. And I think that's about as far as I had to cover. Rob, did you have anything else you wanted to add?
No, not at this point. I thought that was really comprehensive and pretty easy to understand. Excellent job,
Thanks.
as always.
Thank you.
So I want to thank everybody for being on today, and of course, thank you, Andrea. I will be sending out the recording to everyone. If you want to see a customized demo for Creo Simulation, you can just respond to the email that I sent you, or you can contact us at info, at 3hti.com, and we can do a custom demonstration for you if you like. And it's not just limited to Creo Simulation. It can be all things Creo and also all things Windchill PLM, as well as Codebeamer for requirements management and compliance. Thanks again, everyone, for being on, and have a great day.